Okay, hello and welcome back. What we're going to do next is we're going to actually go through some of these problems that I'm going to be posting. These are just sample questions, of course. And what's going to happen is that I'll go through one, and then I'll actually show you the question first, and then I want you to find the formula that will work for you, and then I want you to do the problem. That's a sequence. So one more time, I'm going to give you the problem. You can go ahead and use the formula if you want, and try to apply it. Okay. For those of you guys who completely weren't there or didn't watch the other videos, I'm going to show you right now the formulas. Okay? This is the formula for the nth term of an arithmetic sequence. And if you don't know what an arithmetic sequence is, you're truly in trouble. Okay, they're essentially sequences that just have the same number added to it every single time. This here is the formula for a geometric sequence. All right? For those of you who don't know what that is a sequence that has the same number multiplied to it every single time. Okay? So multiply. Geometric multiply. You remember that? You're awesome. Okay? Next, I have what's called an arithmetic series formula. This formula you're going to use for an arithmetic sequence, but you got to add those terms up for that sequence where remember I said the same number was added to it again and again. What happens if I add those terms up? I would need to use this formula. Okay? So that's that one. And then I have this formula right here, which is called a geometric series formula. This is also one of those formulas you could use, but for a geometric sequence, if I were to add those terms together, this is what I got to use. And this is for a sequence that's finite. And if you want a convergent infinite series formula, you would use this one. Now, for all those videos you skipped, I just showed how to get here, all right? But for those who watched it, they're already ahead of the game. So good job for you honor students who are ahead of the game. Now, what's going to happen next is I'm going to write down, all right, a question, more like an example. And what I want to do is I want you guys to go through it and see which formula to use. First, identify the sequence, find out which formula to use, and you should be fine. So my first question is, find the 17th term of the following arithmetic sequence. And I'll give you the sequence right now, okay? It's going to be 5, 8, 11, 14. And then I'll put dot, 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 because you know what? We don't know what that is. We'll have to figure it out. So let's take a look at that right now. I'm going to let you, you can pause the video. You can look at which formula to use, and then you can find the answer. I'm going to wait 5 seconds, and I'll show you how to get the answer. Okay, so far so good. I hope you found it. All right, the formula you use is, again, the one that you use for an arithmetic sequence. Okay, so the nth term of an arithmetic sequence is really what? Tn, right? And if you look for the formula, it was my a added n minus 1d. For those of you who kind of forgot what each one of these terms were, I'll define them for you. A is the first term. Okay? N is a number of terms I am interested in. In this case, what do you think n is? Okay, well, I'll let you figure that out. And then d is going to be the common difference. All right, not too bad. And I can start subbing all these values in. Let's do it together. What is a? What's my first term? Well, it's going to be this one. This is my a. A equals 5. So I'll plug it in. That's all. That first part's there. Now, man, n? How far do I have to go? You see, n is the nth term that I'm interested in. It's as far as I need to go. And how far do I need to go? Truth is, it's the 17th term, so n is going to have to equal 17. So I'll take 17, I'll subtract 1. What's my d? What spaces every single one of these guys apart? Well, the truth is, here, I'm adding 3 to 5 to get to 8. I'm adding 3 to 8 to get to 11. And I'm adding 3 to 11 to get to 14. So you know what? I know my d. My d is 3. Okay? So let's do this together. If I find out my t of, it's no longer my t of n, I'll write it as t17. It's going to be fine. Okay, I have my 5, and 17 minus 1, you know, is 16, right? I multiply it by 3, okay, and T17 then equals, well, 16 times 3 is 48, okay? My 17th term, guys, is the number 53. Now, if you don't believe me, why don't you add a few more terms to the end of this, okay? Keep going, keep going, keep going, keep going. You will understand that it will end up being 53 at the very end, okay? Because this is when n equals 1. This is here is when n equals 2. When n equals 3, it's 11. When n equals 4, it's 14. If I keep going, keep going, keep going, when n equals 17, it will be 53. And that's how you do this problem. All right, let's do the next problem here. So that was example 1. Let's do example 2. Example 2, and again, I'll pause, or you should pause, and try to find the formula that works for you, okay? Find a formula for the nth term of the sequence 3, negative 12, 48, negative 192. And I'm going to stop there. That was a negative 192. So, one more time, I want you to find a formula for this sequence. And I'm not going to tell you what kind of sequence it is. I'll let you figure that out. Go ahead. Have you found it yet? Well, I don't know what sequence this is. It could be arithmetic. It could be geometric. So I'm going to rewrite this thing a little larger, and I'm going to find out what in the world happened to my number 3 for it to suddenly become a negative 192. Okay? Well, let's find out. 3 to negative 12. Wow, that doesn't look like something was added to it, is it? Well, something was added to it. It's a negative 15, right? If I add a negative 15 to this, though, I don't get 48. So I know immediately that this is a geometric sequence that I have right here. And I just have to find out what my common ratio is. What is my R to get from there to there? What was multiplied to 3 to get to my negative 12? And the answer is negative 4. Okay? Is it true for this interval as well? To go from negative 12 to 48? Does R equal negative 4? And the answer is yes, it is. That totally works. And if you do the work or use a calculator, you're going to find that 4 multiplied by 48 is going to get you negative 192. So wow, okay, looks pretty good. I know my R. If you remember the formula for my nth term of a geometric sequence, is the nth term of a geometric sequence is going to be the following. It's A times R n minus 1. And for those of you guys who forgot what each of these meant, A is your first term. R is your common ratio. And n is the number of terms I'm interested in. Okay? Okay, let's figure this out. All right? Let's just start putting this formula together and we'll see what we can do. Create some space. Next page right here. Kind of see what I'm doing here. Okay. So basically what I've got right now is I know that my nth term equals A times R n minus 1. Do I know some of these values? Well, I think I do. What is my A? It's my first term. It would actually be this right here. This is my first term. So A, in this case, is the number 3. Do I know my R? Do I? I do. It's actually this. It's the common ratio that gets multiplied every single time to each term to get the next one. So to get from 3 to negative 12, I had to multiply negative 4 to 3 to get my next term. To get my next term from negative 12, I had to multiply to negative 4 to negative 12 to get my next term, which is 48, and so forth and so on. My number here is negative 4. Do I know my n? Do I? Let's reread the question. it says find a formula for the nth term. They didn't give us the n. And in fact, sometimes this is how math is. We just want a generic formula for what we got. So in actuality then, this is my answer. Nth term of the geometric sequence. Okay? So that's what that is right there. You're thinking, man, that was really, really anticlimactic. I really wanted some number like the last one. Truth of the matter is, you don't, because now you have you're armed with a certain formula. If you needed to find, say, the nth term of the, like, say, the fifth term, I would put in the number 5, right? Eighth term, I would put in the number 8. The 100th term, I would put in the number 100, and so forth and so on. Let me ask you guys this question. Can I multiply these two bases together? Is it allowed? And the answer is no, you can't. Okay? These bases stay separate because they are different. Okay? So I would recommend that you leave it that way. Okay? And there is an exponent in front of the 3. It's actually this one up here. Okay? It's actually 3 to the 1. So that's the nth term. And that's question 2. Let's do another question together. Let's do example 3. And I'm going to let you again run with this. You can hit pause on the video if you want to run with it. Is find T23 for an arithmetic sequence where T2 equals 4 and T5 equals 22. Okay? So I'm going to let you pause the video and you can take a look and try to solve this. And in about 5 seconds, I'm going to get started on it. Did you find it? Did you find the formula that will work for it? Well, let's give it a shot. Let's see. I mean, it's an arithmetic sequence, right? So I already have a hint right here. So I'm going to underline this. It's going to be hint. It's an arithmetic sequence. They told me already. So I'm in very good shape here. Okay? And you know what else I'm in good shape? I could probably try to draw the sequence out myself. Let me do that right now. Oh, man, I don't know the first term. I'll call it T1. Okay? Do I know my second term? Sure I do. They gave it to me. 4. Okay. Do I know my third term? I don't. My third term I don't know. My fourth term? Still no. Okay? But my fifth term I do know. It's 22. And I'm going to write down T squared right here, just underneath, and T5 under here, just to remind me that I know these things. Alright. So I'm in pretty good shape here. I know my terms. I'm feeling pretty good, except I'm not really far, am I? Because this thing's going to go all the way to T23, and then I'm kind of screwed. So let's think about this for a minute here. Let me see if I can solve for T23 directly. Do you remember what the formula was for an nth term of an arithmetic sequence? And I'll call it AS from now on, just as an acronym. Do you know it? Well, it was the one we used for example 1, wasn't it? It was A plus n minus 1 D. Okay, I'm good to go. Or maybe not. Which one of these letters do I really know? Do I know that one? I don't know A. So T1's not going to work. So I'm going to write down here, no A. Do I know N? Okay, the answer for this one is yes, is 23. Right? And then this one right here, do I know this one? D. And the answer is no D either. So you're thinking, man, Cito, thanks a lot. I'm running to a brick wall. I do not know what